Welcome class, how are you? We're going to be learning about the unit circle today, and you start off with the circle, this circular object right here, and this is the y and x coordinates, and it's in 4 quadrants, so we're going to cut it in like this, and then like this. This is the first, second, third, and fourth. Okay, so now, any questions, classroom?
Where does the 0 go?
The 0 right here, which is also where the 360 is, because you know circles are 360. Then the degrees, these are degrees, right? Not radians. Okay, degrees are 30, and then you have to keep adding 30 to each single one. But you skip the ones in the middle, which is these ones. And then, so now it's 30, 60, 90, 90 plus 30 is 120. 120 plus 30 is 150. 150 plus 30 is 180. And everybody should know that's 180 because it's pi. Then 180 plus 30 is 8, 9, 10, 11. 210. Then after 210 you add 30 again. So that's 240 degrees. Then 240 plus 30 is 270. Then 270 plus 30 is 300, then 330, then you go back to 360. Now to remember your 45, you're going to add 15 to the previous number, so it's 120 plus 15 is a magic number, it's 135. So 135 degrees right here, so then we have to find this one, so it's 210 plus 15 again, it's 225 degrees. Then this one's 300 plus 15, which is 315. So then that's how you find that one. Okay, now any questions, classroom?
How about the radian?
Oh, the radians. Okay. Those have pi in them. Okay, now, this is pi over 3, pi over 4, and pi over 6. To remember the radians, you have to start off with pi over 6. So it's pi over 6, we skip pi over 4. 2 pi over 6, 3 pi over 6, 4 pi over 6. Remember you skipped this one. 5 pi over 6, 6 pi over 6, 7 pi over 6, skip it, 8 pi over 6, 9 pi over 6, 10 pi over 6. Skip this one, then it's 11 pi over 6, right? And then 12 pi over 6. Okay. Well, now you have to simplify the numbers. So 2 pi over 6 is going to be pi over 3. 3 pi over 6 is pi over 2, right? 2 pi over 2. Okay. Then 4 pi over 6 divided by 2 is 2 pi over 3. And then that is an alarm that we're learning because we are smart and learning. Okay, 6 pi over 6 is just pi. 7 pi over 6 is just 7 pi. 8 pi over 6 divided by 2 equals 4 pi over 3. 9 pi over 6 divided by 3 is pi. It's 3 pi over 2. Jesus Christ. 10 pi over 6 divided by 2 is 5 pi over 3. And this one simplifies to 2 pi. And that is where we pause the video. Okay, well now we have to remember the coordinates in the unit circle because those are important. I'm talking really weird. Okay, so all of these are going to be over 2. Yeah, so we're going to put all of them over 2. We have to find what's on the top though. So that should be easy because, yeah, it should. Okay, now we are going to go, this is how I remember it. I don't know if it's the logical way, but it's going to be 1, 2, 3, 3, 2, 1. Right? No. 1, 2, 3, 3, 2, 1. So we'll get started. 1, 2, 3, 3, 2, 1. And all the numbers are going to have, besides the ones, obviously you're going to have a radical on them. So it's radical, 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 radical. And we'll put the And since this side is negative, negative, right. No, negative, positive, it's going to be negative on the x coordinate. Okay, so now we can do this one. So it's going to be 1, 2, 3, 3, 2, 1, and the radicals. And since it's a positive side, they're all positive. This one is different. Instead of it being 1, 2, 3, it's 3, 2, 1. You start off with 3, 2, 1, then it's 1, 2, 3. That makes sense. Okay, since this one is both negative, they're all going to be negative. And don't forget the radical, because you can't forget the radical. Okay. And then the last one, the fourth quadrant, right? Okay. So it's 3. It's the same as this one. So it's 3, 2, 1, 1, 2, 3. And since this is negative, positive, negative, it's going to be negative on this side. And you can't forget the radical once again. Okay. And that is how you do the unit circle. Do you have any questions?
No.
Okay, awesome.
Triangles are a closed plane figure with 3 sides and 3 angles.
This goes on the top, right? And then you find the magnitude
Right
of the
triangle.
okay.
Right triangles can be found in 2 different forms, 30, 60, 90, or 45, 45, 90.
They're all the same, right?
And the right triangles, you use c squared equals a squared plus b squared to find the missing side. You need 2 of the missing sides to solve the right triangle.
That's when we take it.
Law of In law of cosines, you look at the missing angle, and if it's A, use this one. With B, use that one. C, use that one. Or you could use cosine A equals B squared plus C squared equals minus A squared over 2BC. If you can't use the law of cosine, use law of sine. The law of sine is A over sine of A equals B to sine of B and equals to C over sine of C. That's in standard. Where are triangles used? Triangles are used to cut pizzas. Used in architecture, ice cream cones, and it's one of the few shapes that can hold up a lot of weight.
Limits. What are limits? Limits are used to find a range of something. There are several different types of limits. One limit is substitution, and it's x squared minus 4 over x minus 2, and you plug in 2 to the x's, and it gives you 0. So since it's 0, there's no limit. Another type of limits is factoring. You plug in 2 to the x's, and then it equals 0. So there's no limit. Wait.
Wow, dude. I'm just trying to like. What's I squared equals to? What's I squared equals to? I know that's
Another example is
No, then everything else is easy.
x plus 2, x minus 2. You could cross out x minus 2 to both sides, and then you're left with x plus 2, so you use 2 and plug it in for x, and it equals 4, so your limit is 4. Limits are related to asymptotes. They deal with horizontal, vertical, and oblique. Vertical asymptotes, it would be f of x equals 1 over x, 2 equals 1 over 0. So basically you plugged in 2 for x at the bottom, and it left you with 0. So then you do a dotted line right here to 1, and then you do these lines, and it's either positive or negative to infinity. That's why you do 2 of them.